Okay, this question asks us to find a power series for this function. We should know that it has the form of a geometric if we just perhaps re-express this as 1 minus negative 4x squared. So now we can find it and then just put it in sigma notation. So just recall, oops, that's thick. Recall that a over 1 minus r, okay, that is, so long as this is true, is a plus ar squared, etc. Okay, so that must mean that ours, 7 over 1 minus negative 4x squared, can be written as, so first term is a 7. Okay, and then it's 7 times the common ratio, which we recognize as that. So it's 7 plus 7 times negative 4x squared plus 7 times negative 4x squared. Okay, if we simplify a little bit, so actually, notice by the sigma notation that we probably don't want to simplify by combining the 7 and the 4 there, because it doesn't look like that's how they're expressing it. So the question is, which of these sigma notations churn out the right answer here? Let me just maybe write it one more time and then put maybe put the general term in if we can. Okay, so what would our general term look like? Well, it does, so it would be 7 for sure, and then it's negative 4x squared. And then again, there it looks like all of these start at 0. So what we want to do is we want to make sure that when 0 is plugged in, so when 0 is plugged into our expression here, do we get out a 7? Because otherwise we might need to make it like a n plus 1 or something like that, or n minus 1. But I think if we plug in 0 for n, we do get out a 7, and then everything else seems to fall into place. So we should check which one's equivalent to that. Again, it looks like they could be separating the negative 4 out and the x squared. So like notice that this is equivalent to 7 times negative 4 to the n times x squared to the n, which is x to the 2n. I think that's what we're looking for. I think we're looking for that representation. Another way to do this is you could plug in, I mean, you could have to go to the answer choices, plug in 0, 1, 2, 3, and just see which ones match these. But I'm pretty sure if we look closely, what I just wrote matches C.